Hi. In the third part of this tutorial, assembly tutorial, we'll start finally uh, programming our first program. It's a very simple program, and I want also to show you how the panel, the CPU panel in the upper side, help us a lot on the usage of this program. I want to also with as long as we go in the development, you will see how I'm using the app, and you may be able to use the app in the same way. Okay, so first of all, I want to start by showing you that you can change the format of the way in which the information around us is shown. Okay, we can either put it in binary, in hexadecimal, sorry, unsigned decimal, and signed decimal. What's the difference between unsigned and signed is that unsigned doesn't recognize negative numbers, while signed recognizes negative numbers. And if we put it unsigned, the representation of this register with 8 bits allow us to get on as high as 255 as the value 255, from 0 to 255. That will be the range. If we put it in signed, yeah, the range will go from negative 128 to 127. Okay, and it's divided by in the middle, and it goes to the negative and positive. So everything depends on what usage you want to give it. Okay, I will use for now. Okay, to make it easier, I'm gonna keep it in signed decimal. But later on, we'll start using this kind of binary. If we want to, we will learn how to also use this binary representation of all kind of different, for example, computations. Okay, so first of all, my intention of the first program we want to do is to make to add two numbers. Okay, it looks very simple, especially if you already have some kind of programming experience. In this case, we're using assembly. It will be well, it's not so complicated, but at least you will start looking. It's like our hello world version of assembly. How we add two numbers? As I mentioned before, we can always operate we can only operate, yeah, with registers. If you want to use information that comes from outside the app or that is stored in a memory stack or whatever, you have to first put it in a register. CPUs work with registers. The CPU does not, yeah, access directly to the memory or to the hard disk, which means that if you want to use any kind of information and touch it and use it, you have to always put it in a register. So first of all, I'm interested in putting two numbers. For example, if I want to add 5 plus 2, I have to put two different number information in two different registers. And I will put one in the AL, in the lower A register, and the other in the lower B register. How I do that? Well, first of all, you can do, to make it easier, you have to do like this. You move to AL the number 10. You move to ABL, sorry, we said 5 plus 2, 5. To BL the number 2. And let's try to execute this for now. You don't have to program everything from everything before trying it. It's very important to keep trying and see how it represents the information. Okay, so once I feel that I want to try this, I have to stress here, which is an option that compiles the code, which tests it. I mean, what compilation does is it's revise it reviews the code, and it sees that there is no errors, and it tells me if it's ready and everything is okay, and it allows us to execute it later. So I'm gonna compile it, and if I press that, it tells me compilation completed successfully with a happy face. Program is ready to run. So the program is ready to run, which means that I can now run it from the beginning. I want you to see these new buttons that appeared up here. So these buttons allow us to see step by step our code. That's one of the also the reasons I wanted to use this app, EasyCPU, even though it's very old, mainly because it allows us really to see it step by step. You can, let's start by executing step by step. This second option, yeah, will execute the app step by step, and the step will start from here, where the program starts. If we're not sure about where it's going to start, we will see it here in the right side in the code segment. The first value will be the first line of our code. The second value will be the second line of our code, and so on until it ends. So let's start by one first step. You can see that it already jumped to the second because the app is not perfect. Okay, this app is not perfect. It loaded already the lines and it already executed the first line. So it means that the first step already put it in AL, the number 5, as we asked for. We wanted to put in the first register number 5, and we put it. In the second line, what will have to happen here? Here it will gonna be, it should appear here the number 2. And by the way, if you notice, the IP is the instruction pointer. That I didn't mention last tutorial because I wanted to go into it yet, and now we can start showing it. The instruction pointer points to the number here, to the which line of instruction we're executing. In this case, is the line number 2, which is it's going to show the line that's going to execute next, okay, which is this one. Up here we can see which is the instruction that is already, it's going to execute move BL to stu, and once I do this, it moves number 2 to BL. The 2 remaining lines are lines that close the app. If we don't leave these lines alone, if we don't have these lines here, it won't really close the app. We'll see it later, it's the execution of an interruption, okay, just like here. And interruptions are a way for the programmer, in this case us, to tell the computer to execute an event. Okay, we're gonna leave it like this. And if we keep working in it, we keep going, it's going to program end successfully. Okay. What we wanted happened. We wanted to put number 5 in this register, number 2 in this register, and now it's over the app. If we want to add, we have to add another line, which is the add operation. As you can see, once I start editing this, these buttons here disappear. Add, and the question that we have here is what we want to add. We have to add the information in the register AL with the information in the register BL. Adding both those two would look like this. I want to add AL, comma, BL. Commands in assembly are very simple. Okay, you can see as we move the information to AL, we always put the destination register in the left, the origin register in the right, or information in the right, which means that if we put AL on the left, we're telling the system to move the number 5 into AL, to move number 2 into BL. And finally, here we're adding to the 2 registers. But now you're going to ask me where is the information ends, where it ends, where it doesn't. Generally, when we do an adding operation, we have to put, I don't know, A equals B plus C, right? In this case, yes, as I mentioned before, the destination register is always the one in the left. So the resulting operation of adding these 2 numbers will end up in the register AL, which means that we lose the number 5 here, and we eventually will have the sum of these 2 numbers here, which is number 7. If we try it again and we compile it, so remember we compile it up here, the completion completed successfully again, and we start doing the app in step by step. First, it moved the number 5 to AL, but because we already have 5 there, it doesn't really change anything. In the second one, we're going to have number 2. And now it's the most important part. We're going to execute the instruction add AL to BL, which means that eventually we will have here number 7. And let's see, yes, we have number 7. And with this, we finished our first program. From now on, you can keep testing things. You can start playing around with this. You can add, subtract. It's important to understand that eventually processors really have very simple operators. Later on this on combining all these operators, start like building up more complex operators. But that's how everything works upon. I mean, the basic atomic material on which the programming language are based on are the ones that we're going to see here. Yeah? As you can see, we have 5 different operators, which is add, subtract, compare, increase, and decrease. We will be using them, yeah, in the following tutorials.